preparation of phenols, four methods from haloarenes. Haloarenes we have talked about in the first chapter of organic chemistry. Then from benzene sulfonic acid, from diazonium salts, and from cumene. Diazonium salts, basically, this will be used frequently in conversions. Although all will be used, but this is very frequently used in conversion. So from haloarenes, the first one is simple one, which we have talked about as properties of haloarenes in previous chapter. So this is from the previous chapter, chapter 10, organic chemistry. Yeah. So when you get it reacted, the haloarene with the caustic soda at very high temperature and very high pressure, followed by acidic reaction, then you get phenol. Sometimes you will get the same reaction written as NaOH and here HCl 623 300 atm. It is same thing in one step. So in conversions, you will use it like this. From haloarenes to phenol. Then from benzene sulfonic acid, so sulfonic group is there. This is the reaction. First part only tells you how you normally get the benzene sulfonic acid. Normally, this why this is written like this, because normally benzene sulfonic acid is not kept as it is. It is produced from benzene by getting it reacted with oleum. Okay. So benzene sulfonic acid, again similar reaction, but here you don't need very high temperature and pressure. Reaction is very much similar. You get it reacted with caustic soda, okay, acidic environment followed by acidic hydrolysis basically, you get phenol. So previous reaction and this reaction mechanism is similar, only the pressure and temperature different. Oleum is concentrated H2SO4, Ashi. So if you have say H2SO4 plus H2SO4, you will get H4S2O8. But if you remove one water molecule from it, then it is H2S2O7. This is known as oleum. In oleum, if you add water, it will get converted to H2SO4. This is oleum. From diazonium salts, very important. You get diazonium salts from amines, okay, by getting reacted them with sodium nitrite and acid. After that, you heat it with water and you get phenol. One very characteristic property of these reactions with diazonium salt is that nitrogen is evolved. So this will be given as a hint. In few questions, this will be given as hint. And another important point here is that you get HCl back, which you can use again. But evolution of nitrogen is very important feature of this reaction. Write down the reaction and memorize, will be used many times. Then from cumene, the last one. Cumene, first, if you don't know the formula, this is the formula of cumene. When we consider this as isopropyl, then we write it isopropyl benzene. You don't need to write one because wherever it is attached, that carbon will be called one. So you can say isopropyl benzene, or you can say 2-phenyl propane also. That is also acceptable. Isopropyl benzene is actually fumine. When you get it reacted with oxygen, so it is actually in air. This H here is converted to OOH group. So it is addition of oxygen. CH becomes COOH. After that, acidic hydrolysis. This is acidic hydrolysis. But you get a mixture of phenol and ketone here. These can be separated easily because these have different boiling points. Can be separated easily. Now the question. Show how is the following alcohol prepared by the reaction of a suitable Grignard reagent on methanol. So this question, if it appears, you will use the Grignard reagent. Okay. Which Grignard reagent should be used? That will be decided by whatever you have here and what you need. Okay. So I'm just going back so that you can understand. We talked about from Grignard reagents in the previous class, preparation methods of alcohols from Grignard reagent. And we talked about this mechanism, if you remember, that the R gets attached to the carbon because this carbon has slightly positive charge, this R has negative charge, and then we do hydrolysis in second step and we get an alcohol. I'll show you a few reactions so that you can understand. So if I get it reacted with methanol, whatever I need, this R will be decided by the Grignard reagent. It means I need to have that alkyl group in Grignard reagent itself. For example, if I have RCHO, then I will get R and R dash from here. Means it will be 2 degree alcohol. Here it will be 1 degree alcohol. If I have a ketone here and I get it reacted with Grignard reagent, I will get 3 degree alcohol. So in this case, in this question which is asked, we have to use this mechanism, this reaction. So the question is that you have a methanol. So has mic open? I'm muting. So HCHO, and you need to have RMGX, and you need this CH3, CH, CH2, OH, CH. Okay. So first, what will happen? First, R will get attached here, Mg will get attached here, then this will get converted as OH, okay? And it will be primary alcohol. So this C is actually this C, and this is the R which gets attached. This OH is found from here. Okay. In other way, if you want to understand, write HCHO as CH2O. Write it as CH2O. Okay. So this C is one. Hydrogen gets attached. You get H here. This is the R which is attached to the carbon. So that's how you will decide the value of R. And then the reaction is easy. This R will get attached to this carbon. Okay? MgX will get attached to oxygen, MgBr here. And then acidic hydrolysis, this MgBr will get converted to H and you will get alcohol. This is the reaction you have to write. Anything not clear, let me know. Okay, so fine. Just let me know. There are too many students saying they have class. Let me know how many students are going to attend that class, the math class, 7:45. I did not get any chance to speak to Sayyid sir, otherwise I would have got that. How many of you are going to attend that class? Write in the chat box. Okay. 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 So I'm just doing it quickly. So in 15 minutes I'll finish the class then. So many students are attending. Show how is the following alcohol prepared by the reaction of suitable Grignard agent. Again the same thing. You need to produce this one on methanol. So write methanol as first as CH2O, not HCHO. Okay. Then RMGX. And what you need to get? You need to get this and CH2OH. This carbon is carbon, oxygen gets converted to this one. It means the R which is attached here is this one. Okay. So that's how you will get. The process will be two-step process. Okay. Mehak, yes, correct. So R will be actually this one only. You will get CH2 from here. So this carbon is this one. Okay. This carbon got attached here. MgBr got attached here. This is CH2. So write down the reaction and try to write these type of reactions yourself and see whether you are able to write yourself or not. Next question, write a structure of the products of the following reaction. Alkene, acidic hydrolysis, alkene. As a hint, I am telling you this is in accordance with Markov-Nikov addition. Okay, yes, Ashi, correct. So in accordance with Markov-Nikov addition, OH will be attached to the carbon which has less number of hydrogens. The other one will get attached on the other carbon, hydrogen. Vanna, your answer is correct, but not propene, rather propane to all. Okay? Propane to all. There will not be double bond in the result product. So it is actually propane to all, not. . property one. Next, write a structure of the products of the following reaction. NaBH4 is a reducing agent, as a hint. Sodium boron hydride, lithium aluminum hydride, these are reducing agents. So if it is reducing agent, you need to remember hydrogen will get attached to oxygen. Addition of hydrogen is reduction. So there are two possibilities. Hydrogen can get attached here and hydrogen can get attached here also on this oxygen. So both can get converted to OH in this case. Okay. But only this oxygen is reduced by NaBH4. Okay, so there is condition. This oxygen gets reduced, not this one. Okay, because here it is ester. Whether it is ketone, cycloketone, why it is I am saying cycloketone? Because this carbon and this carbon, so it is actually C like this. So it is a ketonic group, but in a cycle, so that's why cycloketone I would say. But this one is ester. So this will get reduced to alcohol. Now reduction you can understand. Okay, reduction. If I talk about acids, will get reduced to ketone, okay, or aldehyde. Normally aldehyde, because there is rare possibility that ketone will get oxidized into acids. So normally, I'm just writing it this time. If I have alcohol, alcohol will get oxidized into aldehyde or ketone, depending on whether it is 1 degree or 2 degree. Okay. Then aldehydes will get oxidized to acids, carboxylic acids. It means when acids get reduced, these will get reduced in aldehydes. Okay. And when aldehydes get reduced, they get reduced in alcohol. And when ketones get reduced, these get reduced in alcohol. Opposite. This is what we have used, this part, reduction part. Ketone to alcohol, which has been used there. So here this is ketonic group. It gets reduced to alcohol. Next, write a structure of the products of following reaction. Again reduction. And this is aldehyde. I just told you, if aldehyde is reduced, it will be reduced to alcohol. Okay. You remember I said aldehyde, when reduced, it will reduce to alcohol. If oxidized, then yes, it will get oxidized to aldehyde. Alcohol will get oxidized to aldehyde. Aldehyde will get reduced to alcohol. These points are quite handy if you remember. Physical properties of alcohols and phenols. Boiling point. We know that OH group in alcohols and phenols is involved in intermolecular hydrogen bonding. And that's why the boiling points are comparatively higher. So boiling points of alcohols and phenols are higher in comparison to other classes of compounds with similar molecular mass. Okay? So for example, hydrocarbons, ethers, haloalkanes, haloarenes of comparable molecular masses will have less boiling point than alcohols and phenols. Alcohols and phenols will have higher. For example, ethanol and propene have comparable molecular masses, but boiling point differ widely. Ethanol has much higher boiling point than propane. These are just indication of those things. Now, solubility. Solubility of alcohols and phenols in water is due to hydrogen bonding. Okay, so alcohols and phenols are soluble in water because they form hydrogen bonding. That's why, with water, right? For example, this is alcohol and these are water molecules. So one molecule of alcohol can have three hydrogen bonds. So one oxygen with two lone pairs can form hydrogen bond with two hydrogens of water molecule. And the hydrogen of the alcohol can form hydrogen bond with oxygen of the other water molecule. So that's why these are soluble in water due to hydrogen bond. Now the question, arrange the following sets of compounds in order of their increasing boiling point. Tell me the answer, write in the chat box. The one which has the minimum boiling point should be first, should be written first. Minimum boiling point. Consider two things, molecular mass and whether there will be any hydrogen bonding and the extent of hydrogen bonding. These are all alcohols. So the answer is very easy. Write in increasing order of their boiling points. There are six. To mention all six. Arohi answer almost correct, but butane 1-ol and butane 2-ol will be interchanged. She include all. Uh, not all written there. Okay. Now see here. Why I say that this one many students have written opposite. Okay. This one is correct. Methanol, ethanol, obviously, and propan 1-ol. But and pentan 1-ol also, because this is increasing molecular mass. So that's fine. Butane 2-ol will have higher hindrance because it will be CH3, CH2, CHOH, CH3, and butane 1-ol will be CH3, CH2, 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 OH. Now attack on this one. If you consider this one, this will be basically tetrahedral shape here on this carbon tetrahedral shape. So the water molecule or other will not be able to attack from these sides. There will be hindrance on oxygen. It can attack only from here. However, in this case, it will be very easier. Okay? It can attack from here, from here, from here, from here. So greater extent of hydrogen bonding means higher boiling point. Greater extent of hydrogen bonding, more hydrogen bonding, or hydrogen bonding is easier here. Hydrogen bonding is easier here. So higher boiling point. Another reason that because here it is branching, you can consider this as branching. So the van der Waals forces will also be lower. Okay. So also the van der Waals forces are lower here.